Hello, so this is our presentation on healthy exercising habits and its correspondence to school performance. I'm David Miller and my group mates are Rio Miki and Patrick Muggy. So our topic revolves around exercise and how it affects school performance. So we know that exercise is seen as an important way to stay fit and better one's mental state. So it's often common by teachers or pediatricians, doctors to suggest exercising to those who are trying to cope with stress, depression, and anxiety. It's really seen as a way to lift one's mood, and it's just a healthy habit. So because a poor mood can negatively affect how students perform in school, does exercising provide a significant boost in students' GPAs? So we have data collected from 581 freshmen at Oral Roberts, and basically what they did was the teacher gave all the students a Fitbit to help keep track of their steps and active exercising minutes. And then once the semester was complete, they measured the GPA of all those students and then also took the data from their Fitbit and recorded all of their activity readings. So for the variables we're using for this project, we first have our y variable, which is GPA, and this is just the recorded GPA of a student at the end of the semester. We then have steps, which is the average number of steps per day recorded by the watch wearer. And then we have our next three variables here are peak, cardio, and fat burn. So each of these kind of corresponds to a different heart rate measurement. So peak is the highest heart rate measurement, and this is the average number of minutes a day where the heart rate exceeds 85% of the maximum heart rate set on the watch. And so this is known as high intensity exercising. So compared to cardio and fat burn, peak minutes are typically the lowest amount of minutes a student would get because it's like the hardest to achieve and the hardest to maintain because it's high intensity. So examples of this could be sprinting or high intensity weightlifting. Then we take a step down to cardio, which is 70 to 84% of the maximum heart rate. This is average minutes a day still, and it's technically called the cardio zone on the Fitbit, but this is more of like jogging, swimming, biking, or just moderate types of sports and exercising in terms of that. So that's where the cardio minutes would come from, and then one step below that's fat burn, which is 50 to 69% of the maximum heart rate, and this would be more like walking or very casual exercising and stuff like that. So typically most of the exercising minutes are found in cardio and fat burn, and then peak would be the remaining exercise minutes, which are typically a lot less. And then we have a couple more variables. We have the gender variable between males and females, and then also age, which we don't actually use for this study, but that's just basically the age of the student. But basically all the ages were between 18 and 22, typical of a college student. We found that this really wasn't applicable to our study. So our research question is therefore, how does a student's daily physical activity as recorded on their Fitbit affect their school performance? So I've actually already researched some studies in the National Library of Medicine that have shown positive correlation, but is there differences between intensities of physical exercise and GPA? For example, are there differences between like peak minutes, cardio minutes, fat burn minutes, etc. on GPA? Are there differences in gender because we have the values of male and females and their corresponding variables? And then also, how does steps, which might not be considered a typical form of exercise, affect GPA? So those are some things we are going to be looking at in our hypotheses. So our first hypothesis has to relate to the number of steps per day and if that has a significant effect on the GPA. So that's what we first want to do is find if the number of steps actually is correlated with GPA. And if so, is there a difference in students who walk more than the recommended threshold 10K steps a day? The 10,000 steps is kind of a national recommendation for everybody to get, and we want to know, given the data we have, is that threshold adjustable or is it pretty like recommendable that we should be getting 10 steps a day? So what can we see from the data here? Our second hypothesis has to do with the types of exercise and if they have a similar effect on GPA. So we really want to know if cardio, fat burn, and peak minutes have similar effects on GPA or do they have differing effects? And so the null hypothesis for this one would be setting all the betas equal to each other. Our third hypothesis has to do with if the steps peak cardio and fat burn affect GPA differently based on gender. So an example hypothesis, we're going to be testing multiple H nulls and HAs, but an example one would be beta 1, beta 5 equals 0, which means that the gender does not make a difference on the steps. There's also beta 2, beta 5 equals 0, beta 3, beta 5, but we'll see more of that later when we start testing it. Okay, so here's our first hypothesis. So the typical recommendation for the number of steps you should be getting each day is around 10,000 steps. So we would like to see if these steps have any effect on students' academic performance first. So our null hypothesis here is setting beta 1 equal to 0, and our alternate hypothesis is beta 1 not equal to 0. So before running tests on our data, we want to make sure that the data is sound and run some diagnostics first. So we first do a lack of fit test, and then we see that a p-value of 0.42 is not significant enough to reject the H null. So we don't reject H null and conclude that the relationship assumed in the model, which is linear, is reasonable. And so we'll be using a linear model for this hypothesis. Then we take a look at the residuals, and we find that we can plot the residuals plot and then the normal QQ plot, and we do see some outliers, especially in the QQ plot here and here, and we would like to be able to transform Y using Box-Cox. The Shapiro test also fails. We have a really low p-value, so we really need to do some transformations to make this data fit better. So using R, we're able to use a Box-Cox transformation, and we find that a lambda value of 2.4 works really well and resolves a lot of the normality issues. So we can see that the data becomes a lot more normal, the residuals, and so that's great. We can move on with our analysis. So we can actually run a really basic scatter plot between steps and GPA, and we do see a positive correlation between these variables on the scatter plot, and a simple ANOVA test will confirm the significance. We see an F value of 117, which is basically a probability of 0, so this is very significant, and therefore we reject H null and conclude that the steps per day does have an effect on GPA. So once we know our significance on steps to GPA, and we've confirmed that in part 1, a much more interesting test is to see what threshold of steps start to have a significant effect on student GPA. So we know that the typical recommendation is 10,000 steps, but what about our lower number of steps, for example 7,000 or 8,000? Are these good enough that we see a positive correlation in the data? Well, so what I did was for threshold values between 5,000 and 10,000 steps, iterating by every 1,000 steps, I subsetted the data such that we're looking at only the students who are within 1,000 steps of this threshold, and then get their sample mean and compare it to the population mean. Then we have the results on the next page. And so here are the results. We have ran it at 5,000, 6,000, 7,000, 8,000, 9,000, and 10,000 steps. And actually, believe it or not, the only significant findings we have here is in the 10,000 steps. We see that this p-value is quite small and significant. Every other steps, even at 9,000, we see that the p-value isn't significant enough to reject the null hypothesis that the sample mean is differing from the population mean, and so actually the recommendation seems to be correct. So we see at 5,000 steps it is actually much lower than the sample mean, and this continues all the way on until we get to around 9,000 steps where we really start to see the sample mean increase over the population mean of GPA, and then finally at 10,000 steps we see a huge increase of the sample GPA over the population GPA. And so basically what we have found is that starting at the 10,000 step threshold, student groups with less than 10,000 steps failed to reject H null, and we concluded that their GPA was not significantly greater than the population mean. But student groups with greater than 10,000 steps did reject the H null, and so we concluded that their GPA was significantly greater than the population mean. So we do find that the recommendation of 10,000 steps is actually very applicable. It's actually completely accurate in this scenario, so that's kind of an interesting find. So now moving on to our second hypothesis, we're now looking at the average time spent in cardio, fat burn, and peak modes, and do they have a similar effect on GPA? So our null hypothesis will just be setting the betas equal to each other, beta 2 equal to beta 3 equal to beta 4, and then our alternate hypothesis is the full model, which you can see here. Because we're using different variables, we do want to run another diagnostics test, so we do want to check for multi-collinearities between these variables because, they could be correlated. They are measuring different forms of exercising. So we look at the scatter plots here and then look at the correlation, and we actually don't really find any correlating values. So we're actually fairly confident that there isn't any multicollinearity in this data set. However, we still can take this a step farther by using the VIFs. And so by checking the VIF stays constantly low for all three variables, hovering around 1, and there is no dramatic increase or decrease that would lead to multicollinearity issues. So after the two tests, we can confidently say there is no problem with any multicollinearity, and we can continue on to our diagnostics. So similar to hypothesis 1, after looking at the residual plots, we do seem to have some normality issues that we would like to fix in this type of data. And the QQ plot does seem to show normality issues. So we look at the Shapiro-Wilks test here, and that is a p-value of basically 0 again. So the Shapiro-Wilks test rejects the null hypothesis, and thus the data violates from a normal distribution. Therefore, we're going to have to use another Box-Cox transformation for this. So here's another example of using the Box-Cox transformation. We have an example code right here. Because there's a normality issue, we use the Box-Cox transformation, and the lambda value is actually basically calculated to be the same, 2.39. So we can make this the new model. And then we have another QQ plot here that just shows that it's straightened out. So now we can move on to our ANOVA testing. We look at the analysis of variance table, and we find that the F-score is 4.227, which is greater than our critical score calculated to be 2.62. Therefore, we reject the null hypothesis, allowing us to use the full model. Therefore, in conclusion, the ANOVA table and the F-value is used to see if beta 2, beta 3, and beta 4 equal each other. And because we're rejecting this, we find that they actually do have different impacts on the GPA. They don't all affect GPA equally. So the implications that the three modes of exercise affect GPA differently allow us to kind of consider an interesting study which could determine which mode of exercise has the most positive impact on GPA. For example, does peak physical exercise have more positive or negative associations to GPA than cardio, for example? Or vice versa, or basically any combinations of fat burn, cardio, or peak. So that would be a really interesting study to consider for the future. And lastly, our hypothesis 3 is now going to consider the different GPA effects based on gender. So a lot of these, we're going to run through, I think, 4 hypotheses here. We're basically seeing does steps make a difference based on gender, etc. So the first model is steps. And the results show that we get a F score of 2.257, which is smaller than our critical value of 3.856 calculated on the previous slide. Therefore, we do not reject H null and conclude that the gender does not make a difference on the relationship between steps and GPA. The second one we want to consider is if gender differences make a difference on the peak to GPA relation. So we have the same F score for this one. And in this case, we reject H null here because we have an F score of 8.385, which is significant, and so we conclude that gender does make a difference between the relationship of peak and GPA. Part 3 of this hypothesis tests if gender makes a difference or not on the cardio to GPA relationship. And the results here are similar to with the part 1, where the F score is too small to be significant, and we do not reject H null. So we conclude that the gender does not make a difference in the relationship between cardio and GPA. Lastly, we test the the gender differences between fat burn and GPA relations. And similar to part 2, we have a significant enough F score to reject H null and conclude that the gender does make a difference in the relationship between fat burn and GPA. So these results are kind of interesting because some of them are significant and some of them aren't. So why do we see significant differences in some of these? Well, we did some research and it's actually quite unclear. It does indicate that the future research can be done examining the differences in exercise between genders. For example, how does the means of peak minutes compare for males and females? Like, do males exercise more peak minutes on average than females? That's something really to consider. So if there is a significant difference, how does that correspond to their GPAs? So to conclude our overall project, we found that steps and exercise have a significant impact on GPA, And the 10,000 step threshold is actually a really good recommendation to find the positive correlation between steps and GPA. We found that different forms of exercising based on heart rate have different impacts on GPA, so it would be interesting to know which types of exercise has the most positive impact on GPA. Then finally, we found that gender differences vary on type of exercise, so we found significant differences in fat burn and peaks minutes, while there aren't any differences in cardio or daily steps. So all of these kind of indicate there's a lot of future research that could be done in this area. Thank you for listening.